once again welcome you all to my channel CSNet Lectures. So in the last classes we discussed regarding different types of stack problems, that is very important problems. So in this session also we are going to discuss on one of the very important stack problem that I have written over here. We shall see the question. Okay, so before understanding the how to solve the answers, first you must have to clearly know what is the content that is being given in the problem statement. After that we can go for solving, isn't it? So now see the problem. A single array A of 1 is to max size is given. Okay, it is used for implementing two stacks. That is, we are going to use an array structure. In that array you are going to implement stacks. That is, an array is going to hold two different stacks. The two stacks grows from opposite ends of the array. Okay, so we are going to implement two different types of stack data structure in a single array. So while inserting the elements, the pointers of both the stacks is going to grow in the opposite direction. Okay, so the variables top 1 and top 2 points to the location of topmost element in each of the stack. Okay, so from the question we can know that the topmost pointer name is top 1 for stack 1 and top 2 for stack 2. So the condition of the topmost element values are, that is, the topmost pointer value should be top 1 less than top 2. While incrementing, we must have to check this condition. Okay, then if the space is utilized efficiently, what is the condition for the stack is to be full? Okay, if the array and the two stacks are suppose used properly, what is going to be the condition for the stack is full? Okay, so that we are going to implement. So among the four options, okay, by doing the manipulations, we must have to find which of the option is going to be correct. Okay, so to find the stack is full, what pointers will be using for finding this answer? So the pointers top 1 and top 2. We are going to use these topmost pointer values for checking the condition for the stack is to be full. Shall we implement it? So now watch keenly. So what we are going to implement? A single array. So we are going to implement an array. Okay, right? This is going to be an array. Okay, for example, suppose if I am going to store 10 elements in an array, for an example. So let the max size be 10. So 1 to 10 elements I am going to store. Okay, so what is the maximum size of the array? So it is going to be 10. So now shall we draw that is the 10 memory sizes for this array. So how the array memory locations will be pointed? So we are going to use an index value for denoting the element that is stored in an array. So an array is going to have the index value starting from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now in this order we are going to store the elements. So now we have drawn the array data structure. So as it is being given in the question, in the single array we are going to implement two different types of stacks. Okay, so how we are going to implement two different types of stacks? We are going to divide this array into two stacks. How we can divide? For example, shall we divide this into equal halves? We can do it because 1 to 10 elements have been given. Okay, so 10 divided by 2, what is the answer? We can get 5. So now you give 0, 1, 2, 3, 4. That is up to this to stack 1. Then the remaining equal half you give it to stack 2. Okay, so here we are going to use the pointer named as top 1. Here we are going to use the pointer name as top 2. Okay, so as in the question they are given, the stack grows in the opposite direction. Okay, the two stacks pointers are going to grow like this. Okay, it is going to grow in the opposite direction, not in equal direction. So like this, we must have to store the values. So now at present, let the top pointer be here. Let for the stack 2, the pointer be here. This is top 2 and this is top 1. Now, as we go on as we go on insert the element, the topmost pointer is going to grow, isn't it? Shall we see? For example, I am going to insert some elements, 5 elements. So, 22. The pointer is going to increment here, isn't it? So now 23. Then in this pointer 28. Like this, I will be storing, incrementing the pointer, and I am going to store the value 30. And at last, the pointer is going to point to this location, isn't it? So top 1 will be pointing to the topmost location. Let the value be 55. Like this, I have inserted. Now in stack 2, I am going to start inserting the value. See, now you see the top one pointer is moving like this, isn't it? So now while I am going to insert the elements, the pointer is going to move in this opposite direction of that of top one. So as we go on insert the elements, both the pointer will come to a place where they are going to join together. Okay, so see, now I am going to start inserting the elements. So let the values be 11, and here pointer is being moved, so let the values be 15. Okay, again I am moving the pointer, let the value be 18. So now I am going to insert the value, let the value be 19. Again I am inserting the value, let the value be 61. So now where is the pointer of top 2 is present? So the pointer of top 2 is present. So now if you keenly notice, what is the condition for the stack to be full? That is, when the pointer is pointing to a location which tells the stack is full. Here it is top 1. So the top 1 reaches the maximum size of the stack when the index value is going to be 4. Isn't it? For stack 1, okay, when the index value is going to be 4, it means that the stack is full, isn't it? Now, in for stack 2, if you see, that is the top 2 pointer, when the stack 2 will be full, the top 2 is reaching the maximum size of the data structure. That is the maximum size of the stack data structure. So here, when the index value is 5, okay, when the index value is 5, the stack is going to be full for stack 2. Yes or no? Yes. So, when the stack is going to be full, at that time, the topmost pointer value will be the index value of the stack 2. So, what is the index value? Is 5. So, now the top 2 pointer is pointing to this location. Isn't it? Now we check the answer. Which is going to be right? So, I have got the condition for stack is full. So, this is a proper condition. Okay, when the stack is going to be full. Now, you check all the 4 options. Now, you see top 1 plus top 2 is equal to max size. Is it true? Top 1 value is 4. Okay, then top 2 value is 5. So, what is the max size value? So, the max size value is 10. But when you add this, you are going to get only 9. Isn't it? So, this option is wrong. Okay, now we check the second condition. So, the second option they have given is top 1 minus top 2 is equal to max size. Is this condition true? So, top 1 value is 4 and top 2 value is 5. When you minus this, is it possible for you to get the max size value? The max size value is 10. But if you minus this, you are going to get the difference as 1. Exactly, if you want to tell, it is minus 1. So, this option is also wrong. So, now you find the next condition. So, the next condition is top 1 is equal to max size by 2. So, what is max size? So, max size is 10. Isn't it? Then, if you divide it by 2, you will be getting the answer as 5. But what is the top 1 value? The top 1 value is given as 4. So, this is also wrong. Right. So, now you check the last option. So, top 1 is equal to top 2 minus 1. If you substitute the values of top 1 and top 2, you are having the possibility of getting this answer. So, what is the value of top 2? 5, isn't it? So what is the value of top 2? It is 5. When you minus it from 1, you are getting the answer as 4, isn't it? So what is the value of top 1? So top 1 value is also 4. So both are equal, isn't it? Now among the 4 options, which is having the right or proper answer? So the fourth option is having the proper answer, isn't it? Are you clear? Right. They may also change this right option into a different manner. Okay, I'll tell you how. For example, they will give as top 1 plus 1 is equal to top 2. This is also right answer. Okay. So if this is given, it is also right. Suppose in this format if they are given, this is also right. Okay friends, so this is the way of solving this type of stack problem. Okay, are you clear with it? So in the next session, I am going to discuss another one important stack problem. Okay, so thank you friends. Thank you.